I think this is going to be the last one, which is on probability for the moment. For those of you not doing your A-levels this year, we'll try do the other ones, which you can obviously use as practice. So probability. Generally, you've only got a few rules. This should be an easy topic. So if things are independent, then the probability of A times the probability of B equals A and B. That doesn't mean, so it means they can happen at the same time, but they're not connected. Kind of like me wearing, I don't know, a red night dress and you guys somebody wearing blue socks. They can happen on the same day, but they're totally independent and not connected. Mutually exclusive tells you they never, ever, ever happen at the same time. So the probability of A and B would equal 0. So if we look at this question, we've got write down any pair which are mutually exclusive. So any pair that don't intersect at all. So we could have A and C. We also could have had D and B. We also could have had D and C. So they don't meet each other. It says, given that the probability of B equals 0.4, so it's telling you that this entire circle is 0.4. So you've got to find the value of P. So that's nice and easy. You're doing 0.4 minus 0.24 minus 0.07, which gives you 0.09. Now we're told A and B are independent. You see that, your brain's going to go, okay, it means the probability of A times the probability of B equals A and B. Right, so the whole of the probability of A, which is 0.24, so everything in that circle of A, you've also got the whole of Q in there, times the probability of B, which we know is 0.4, equals A and B, which is where they meet, which is 0.24. So we're going to divide, so you're going to divide 0.24 by 0.4, which gives you 0.6. So 0.24 plus 0.16 plus Q equals 0.6. Therefore, Q equals 0.20. And they now say, given further that not B, so this is not B, you've got B with a dash next to it, given C. Now, all given means is that you've made your world smaller. So it means given C means now all I care about is this circle. I just care about C, right? So out of everything in C, not B over that equals 0.64. So what we're saying is how much is not B? So not B out of just this circle, because this is all I can care about, is R. Divided by the whole circle, which is P plus R. We know all of that equals 0.64. However, we know that P is 0.09 because we already calculated that. So we get R over 0.09 plus R equals 0.64. Multiply it up, 0.64 multiplied by 0.09 plus R. So we end up with 0.3, so 1 minus point, so 0.36 R equals 0.0576. And so R equals 0.16. So you've got R equals 0.16. So we now have, this is 0.16. We know that this is 0.09. We already calculated Q, which is 0.2. We know that the whole box has to equal 1. So we do 1 minus all the numbers that are left, and that leaves us with S, which is 0.08. So 1 minus 0.16, 0.09, 0.07, 0.24, 0.16, and 0.2. Okay, next question. No, not letting me change question. Oh, there we go. 3 bags, so loads of words. I don't like words. I think that's why I did maths and then physics, but anyway. Right, so 3 bags, 1 red, some green, Sasha selects a random 1 marble from bag A. So we're starting off with bag A, and we're going to end up drawing a tree diagram, so let's start. So from bag A, we've got 2 options. We're either going to collect a green marble or a red marble. And a green marble is 9 out of 10, and a red marble is 1 out of 10. If he selects a red marble, he stops, okay? So there's going to be no lines coming out of it. But for green, he keeps going, okay? So red, green, so that's going to be 4/5 and 3/5. Oh, sorry, 1/5 even, sorry, because it's 1 red. And if it's red, he stops again. So green and red. Green is going to be 2/3 and 1/3. Okay. Find the probability that it's 3 green marbles. So if it's 3 green marbles, we're going green, green, green. Along a branch, we always multiply. So for part B, it's just 9/10 times 4/5 times 2/3. Gives you 12 over 25 or 0.48. Find the probability that Sasha selects at least 1 marble of each colour. Now it's much easier to do that she selects, well, she doesn't select that, or you can just look at all, actually, you could probably just look at all the different combinations. So she selects 1 marble of each colour, means she could go green and then red. So 9/10 times 1/5. So along branches, between branches, so or she could get 2 greens and a red. So green, green, and then red. So 9/10 times 4/5 times 1/3. We could have done 1 minus the other options, but I think in this case, it comes out almost the same. So I get 21 out of 50, so 0.42. Now it says given that she gets a red marble. So that means we don't care about, we only care if she gets a red marble. So it's only out of certain options. So in what times does she get the red marble? So let's have a look. So red marble would be this option, or green and then red, or green, green, and then red. Okay? So the only way she doesn't get a red marble is if she selects 3 green marbles. So what you could do is do 1 minus the answer you got from B, instead of doing each of the individual bits. If you did the individual bits, you get the same answer. So 1 minus 12 over 25 is going to give you 13 over 25. So we'll have 13 over 25 on the bottom, because that's what it's out of. So out of those highlighted bits, find the probability that he gets it in bag B is going to be this option. So 9/10 times 1/5. And we calculate that and we put it down on our calculator. We get 9 out of 26. Right, question 3. A company maintains machines. It has 2 types of contracts. It plans to sample 100 of its customers using stratified sampling. So that's just using the same proportions as what's there. So we want to have new customers, so new customers with repair contracts. So that's 82. So we're saying at the moment, what's the total amount this is out of? So 82 plus 262 plus 65 plus 231. The total here is 640. So they're saying instead of having all 640 customers, they're only going to have 100. But we want the same proportion. So 82 out of 640 times 100, which gives me 12.8.1. Now I can't have 0.8 of a person. We're talking about people here. So we're going to say it's going to be 13 customers. We're going to round it up. Okay. The company collects some information from a randomly selected machines. 2% have a fault. Okay. 70% of the machines with the fault test positive for the fault. 10% without the fault test positive for the fault. Okay, so I would probably draw a tree diagram for this. So it starts off with a machine having a fault or not having a fault. So I'd say the probability of a fault is 0.02. The probability of no fault is 0.98. Okay. Now, 70% of the machines with the fault, so with the fault, test positive. So out of that, the probability positive, let's put plus sign there, I guess, equals 0.7, and the probability negative, therefore, is 0.3. 10% without the fault, okay, that's not sounding like a good test, but okay. Test positive, and that means 90% test negative. A machine is selected at random and tests positive for the fault. So first we've got to find who's testing positive, or which machines rather. So the machines that are testing positive is fault and positive, or not fault and positive. So those are my possible branches. Right, so my possible branches, so 0.027, 0.02 rather, times 0.7, plus 0.98 times 0.1. So those are the possibilities. Now it's saying that's what I'm starting with. I only care about those two branches. So those two branches together give me, if I multiply that up, gives me 0.112. And now we're saying out of that, calculate that they have a fault. So have a fault is just the top bit, which was 0.014. So this is going to be 0.014 out of 0.112. Stick that into my calculator and it gives you 0.125. Now that is not great as a percentage. Okay, that's the next bit. I hadn't read that. Comment on the usefulness of the company's test. Well, I'd say most machines test positive do not have a fault. So it's not a very useful test. Like, it's just not useful. I mean, you can see that quite obviously. So when the company services the machine, it checks two components, alpha and beta for wear and tear. Event A is that alpha needs to be replaced. Event B is that beta needs to replace. Okay, so I'm going to think of this as a Venn diagram. I like pictures. Some of you might just be able to picture it in your head. And it's saying the probability that neither, so we know 0.28 is on the outside. So that means everything in the circle bits has to equal 1 minus 0.28, which is 0.72. Okay, so we know that's the case. We know the probability that A needs to be replaced, so the whole of A is 0.35, plus the whole of B, which is gives you 0.9. But we've only got space for 0.72. So if we minus the 0.72, that's going to give us the amount that's in the middle. So if I was going to fill this in, I get 0.17 and 0.55 minus 0.18, 0.37. So that's kind of what my Venn diagram looks like at the moment. And we're going to say, okay, show that they are not independent. So remember, the rule for independence is that the probability of A times the probability of B equals probability A and B. So let's try this. Probability of A is 0.35 times 0.55, stick that into your calculator, you get 0.925, and you say this is not 0.18, so not independent. Find the probability that A or B needs to be replaced, but not both. So we've already done that work. Essentially, all we're looking for is these numbers on the outside. So A on its own and B is on its own. So we're just going to add those two numbers up. So we'll have 0.17 plus 0.37. So 0.37, 0.17, and that gives you 0.54. Okay, next question. Right, question 4. That's not enough space. So let's do that. Right, given that A equals 0.35, so this again is really similar to the question that we're looking at. I would always start these with like drawing a little Venn diagram because I think it's so much easier to see. So you've got A and B. We're told the bit in the middle is 0.13. So that means we can work out 0.35 minus 0.13, which gives you 0.22, must be this bit on the outside. 0.45 minus 0.13, which is 0.32. And then 1 minus all of that gives me 0.33 on the outside. Right, I know there's a formula for given, but it's much easier if you just understand what they're trying to ask you. So whatever is out after the line, this is your given line, not B. That's what we're looking at. That's all we care about. We're making our world smaller. We just care about the things that are not B. So what things are not B? This is not B, and this is not B. So in total, the amount that's not B is 0.33 plus 0.22, so 0.55. Out of those two things, how much is not A? Well, out of those two things, 0.33 is not A. Stick that, well, you should be able to see it's 33 over 55, which is the same as 3/5, or 0.6 if you've got it in decimals. And then it says explain why they are not independent. Exactly what we did before. 0.35 times 0.45 equals, so 0.35 times 0.45 equals 0.1575, which is not 0.13, therefore not independent. Okay. The event C equals 0.2. A and C are mutually exclusive. Okay. A and C never touch. So A is going to be far away from C. And B and C are statistically independent. Okay, so now we're drawing a new Venn diagram. So let's make a bit more space, draw it here. So we know that A and C are mutually exclusive. They're not going to touch. So we're going to have A, B, and C. So A, B, and C. So A and C are not touching. And we know that C is 0.2 and it's independent with the 0.45. So we can work out, sorry, not with, yeah, B and C are statistically independent. So we know the probability of B and C is the same as 0.45 times 0.2. So when we do that, we get 0.45 times 0.2, which gives me 0.09, which is going to be this bit in the middle of B and C, which means we can work out the rest of C, because we're going to do 0.2 minus 0.09. So we get 0.11 outside here. We already know that A and B is 0.13, so we can fill out this bit. The whole of B is 0.45, so if we minus 0.13 and minus 0.09, we end up with 0.23. And if we do 1 minus all of those numbers, we get left with whatever should be on the outside, which is 0.22. Okay, let's check that's right. Have I done that right? 0.2, yeah, should be right. Okay, and now what are we finding? 0.45 times 0.2, 0.45 times 0.2. Oh, I should fill that out here just so you've got it complete. Now we want to find B or C not. Okay, so before we do the not bit, let's figure out what it means by B or C. So that's essentially saying, let's get a highlighter, everything in B or everything in C. And we want not that. So essentially, we want all the numbers, the amount that we've not highlighted, which is 0.44. So you're just literally going to fill that out. That equals 0.44. And you're done. Right? Probability is nice. It's like the bit of statistics I like. So last question. This one is more, I guess, mathsy is the way to put it, but like more pure maths-like, if I'm not mistaken, if it's the question I recognize. Right, so two events, A and B, are mutually exclusive. Okay, we know they exist in their own bubbles. They're never going to cross. Okay, given that the probability of B is P, okay, and the probability of A is 3 lots of that, oh, okay, fine. We've drawn a Venn diagram. And then outside, the whole box has to add up to 1. So 1 minus 4p will be on the outside. And then it says, find the possible values of p. Well, we know everything. I mean, you could have 0 on the outside. So essentially, we know that 3p plus b has to be between 0 and 1. So 4p has to be between, well, it can't actually equal 0 because it has a probability. So it has to be greater than 0 and less than or equal to 1. So divide both bits by 4 and you get 0 less than or equal to a quarter. So those are your possibilities for p. And I think they've called it the probability of b there. Let's just write probability of b. Okay. Two events, C and D, are such that the probability of C given D equals 3 times probability of C. Explain how they can't be independent. Now, it gives you this in your formula book, but you could probably also work it out because you're given the probability of A given B is A and B over the probability of B. So C given D is the same as C and D over the probability of D, but if they were independent, they would be multiplied by each other and it would cancel out. But your formula book actually gives you that if they were independent, so your reason it can't be true, the C given D would just be the probability of C because they don't care about each other. So it doesn't matter if one is given or not. And now we've got to work out the probability of C given some information. So I'm going to clear this and scroll up just so I've got some more space. Right. So now we're going to actually use the formulas. So we know C given D. So we know the probability of C and D divided by the probability of D equals 3 lots of the probability of C. Okay. We also know that the probability of C and D is a half the probability of C. So now we can substitute that into here. So we get 0.5 probability of C over the probability of D equals 3 lots of the probability of C. There's C on both sides, so those cancel. And now we found our probability of D, which will give us 1/6. So now we've got our probability of D, which isn't what we want yet, but most of what we want. And then we're given the probability of not C and not D. So that's the bit, if you think of like a Venn diagram, that was C and D, that's the bit on the outside. So 1 minus it will give you the bits on the inside. So 1 minus 7/10, which equals 3/10, must be C or D. Okay, now in the formula book again, you're given that the probability of C or D is the probability of C plus the probability of D minus the probability of C and D. So C or D we know is 3/10. Probability of C is what we're trying to find. We know the probability of D is 1/6, and we know C and D is a half lot probability of C. So we can combine the numbers together. So 1 probability of C minus a half probability of C gives me a half PC. And then I can do 3/10 minus 1/6, which is going to give you 2/15. And so that means the probability of C must be 4/15 if I multiply by 2. And there's your 7 marks. Okay. I think that's the last question. Yes. So those are the probability questions. Remember, with probability, they're just a few rules. Probabilities always between 0 and 1. If they're mutually exclusive, never, ever can happen together. And if they're independent, the probability of A times the probability of B is the probability of A and B. Right? Anyone with assessments this week, good luck. I'm sure you'll be absolutely fine. We've survived a lot worse by surviving the last few years. And yeah, you're going to be okay. And hopefully this has helped a bit.